No, I've never done this. I just made this up when you said no to fire.
1558.
When does this due?
All right, you're on camera.
Alright, hold on. I need
On the video. We'll get it on video.
Alright, the first one is 1.56 seconds.
All right, Genevieve, whenever.
Wait, don't.
We got 2. Doubling.
Oh my gosh. Okay, I got it. Got it. You can go whenever. Go! Oh my gosh! 2.34.
Acid! Actually, that's true.
Yeah.
Yeah. And base. We're freebasing. That's what we're doing. We're freebasing. Sorry, you got the messy part. Actually, my coat's probably pretty.
Well, I almost got the messy part though.
Duck and cover, duck and cover. Wait, we're moving. That's.
Yeah, try and get it closer to the thing, because I'm going to record the impact of it. We can use it in our video. Actually, drop it on his iPad. Yeah.
Go!
Alright.
So we can set the time.
1:59.
Overflowing as soon as it hit. Yeah.
Especially this one?
Especially by the time I got the third violin, it was really
A foamy ball.
almost just like done foaming.
Yeah. I wonder if that's why the times were less. Because the third one is like the second biggest time, and then the first one is the lowest, and then the second one is the highest time.
Okay. So, well, flip it back to me. Actually, hold on. I want the front camera back. Oh, don't tell me you're not going to flip on me. I'm just wondering, when we did the third trial, did we flip from rate limiting in baking soda to rate limiting in vinegar or acetic acid?
True.
We're going.
Cool. Alright. Hey all. Alright, so our little experiment that we conducted with tennis balls was the combination of a tennis ball that we hollowed out, or opened up rather, put a little bit of baking soda in and vinegar, and made it drop.
And we had to do that because you're evil and you wouldn't let us burn them.
So,
MSDSs be damned.
Alright, so kind of the setup that we did, of course, like I said, cut open the tennis ball. We had to weigh all of our tennis balls. We used 3 of them. And from there,
Put the same amount of baking soda in each tennis ball, and we did an increasing amount of vinegar. So the first amount, then we doubled it, then we added basically another same amount, so it was triple the initial amount each time.
And then we proceeded to go up to the last floor of the parking ramp and drop all 3 tennis balls. The first one, which we got a time of 1 minute and 56 seconds. The second one was 2 and 34 seconds, and the third one was a minute with 59 seconds. Our discrepancy there is the second ball, which had double the amount of the first one, which had a time almost double the amount of the other ones.
We don't know why.
Yes.
So I'm going to stop this here for a... So the first thing we did was we sort of compiled all our numbers and did a few little calculations that I looked up from my old physics book just to see. And then our first thing was our pie chart. Notice we're not going to show you potential energy because looking at a circle that would be all one color would be boring. If you look at the numbers, you're going to see pretty much the same effect all the way at the end. It's going to look something like that. Our question again was we were trying to simulate energy loss due to chemical bonds being broken and released, and you can see that there's quite a lot of chemical energy lost from your potential energy that you never get back. So if you had, like, say, potential energy that was all purple, time would go as you would see more and more and more red and blue showing up until eventually it all becomes red at the end. And so we're going to start with our weird stuff now. When you see that because of the one oddball time, we're not sure if this effect should be like more U-shaped or it should be more linear with some of the third point being up here. That'd be something we'd want to look at again. And the same effect with the masses versus the kinetic energy is you see pyramid, and we're not sure if this one or this one is the oddball due to the odd time. Should it be down here, more linear, or should it be flatter, or should it be more steep with something up here? That would be something we'd want to investigate over more and more time. Rolling.
Alright, so I guess we'll dig into our initial thoughts before we started this investigation. Personally, I didn't know what to think about the chemical aspect of it. I was just thinking mass, velocity, time, putting it all together, what's going to happen. So my initial thoughts were we would see an increase as we went on. So first drop would be a little bit slower, and we would increase from there. Third drop would hit a little faster. So those were my initial thoughts on that.
Yeah, same here. I immediately thought of masses and how it would correlate to kinetic energy. So with those pie charts, I saw that kinetic energy increased due to the chemical nature of baking soda and the reaction of the baking soda and the vinegar. So with that chart that Paul showed, I thought it'd be linear instead of that parabolic shape it has there.
My initial thoughts was I knew they were all going to fall approximately at the same time, so I was really surprised when they didn't. Thank you, Mr. Galileo. I knew chemical potential energy is a significant amount, so I knew we were going to lose a lot. I didn't realize that much, and I am sort of surprised that we did have the nonlinear thing, and we might have a thought behind it, but we're really not sure on that.
Mm-hmm. So after doing our investigation, our thoughts now, my main thought that comes into mind is just doing this over and over again, because I think there are some discrepancies. I was the one up top pouring the vinegar into the tennis ball, and the first thing I noticed was when you're only using one vial, you still get the reaction when you drop it, but if you're trying to add 3 vials at once, it's reacting, and by the time you drop it, you just have a tennis ball filled with vinegar. So yeah. I think if we conducted this multiple times, we might get some different results.
Yeah, so I guess maybe using 1 vial for all, but each vial increases in size, so that's why it's just 1 vial.
Mm-hmm.
Yeah. It's also, because like I said, we were trying to use this as a proxy for fire. Because we figured that's releasing CO2, so this was releasing CO2. And like I said, all 3 of us thought the big surprise was we were expecting something straight-lined.
Mm-hmm.
As far as whether we looked at energy, mass, time, any combination that we were expecting straight line, not this up and back forth. The pie charts we pretty much thought go away. Okay. We've been pie charted to death.
How has your thinking changed during these investigations?
Boy, how has my thinking changed? That's a good question. Did you want to start off with this one?
Am I thinking?
Yeah.
Not really. I think I'm still, my thinking is I'm going back to things that I already know. So when you're trying to aim an experiment that's probably more aimed at junior high, middle schoolers, I having a hard time going down still to how they're thinking.
Mm-hmm. Mm-hmm.
Yeah.
Yeah, I think that's a big challenge, especially with something that has a lot of variables, like an experiment like this. It would be hard. In my case, when I'm wanting to do elementary, something like this might be a little bit complicated. It'd be fun, but it'd be a bit of a challenge to kind of get the point across.
Yeah,
So.
because I feel like different students would look at different things, like kinetic energy or acceleration, just the chemical reaction within those tennis balls, I guess. So,
Yeah.
different ways to go from there.
Right. But we enjoyed the experiment. It was a good time. Fire is our next step, whether it's here or someplace else.
Rebreathers.
Yeah.
Bye.